Hello children, this is class 10 assertion and reasoning questions, chapter 4 quadratic equations. For assertion and reasoning questions, you will be given two statements. First statement is called an assertion, second statement is a reason. You will be given four options to solve this question. Option 1 will be both A and R are true and R is the correct explanation of the assertion. Second option will be both A and R are true, but R is not the correct explanation of the assertion. Third one, R is false. Fourth one, A is false. So among all these options, when you see if any one of the given statement is false, you can go for option C or option D. The third one is option C. The fourth one is option D. But both are true. You have to go for any one of these options, A and B. When will you go for A? When both the statements are true and the reason gives a correct explanation to the assertion, you go for option A. If the reason has no connect, it is not explaining the assertion, some other way reason is true and assertion is true, you go for option B. This is the method of solving the assertion and reasoning question. Where do we have assertion and reasoning question? We have 20 MCQs in section A in our test paper. Out of the 20 MCQ, question number 19 and 20 are based on this assertion and reasoning. To solve this assertion reasoning, here I told correct explanation. So A and R have a connect. How to check whether it is a correct explanation of assertion, whether the reason is an explanation of assertion. For that you can follow this rule CUTE. C means connect. That means the statement of reason and assertion have a connect. Both should be about the same thing. Then use. The assertion is using the statement given in the reason. Tells. The reason should tell about the assertion or explain about the assertion. Tell means simply it will be telling about the concept. Explain means it is a elaboration of the assertion. Like that, you can use this clue to solve this assertion and reasoning. Particularly, this tip is used when both the statements are true. We'll see practice question. Question 1. 2x minus 1 the whole square minus 4x square plus 5 equal to 0 is not a quadratic equation. Wherever you are getting a not statement, please underline, read it twice and understand the statement well, then go for conclusion. Reason. An equation is of the form ax square plus bx plus c equal to 0, where a is not 0, a, b, c belongs to all the real numbers, are called quadratic equation. That means if the coefficient of x square is not 0, that is a is not 0, then it is called a quadratic equation and the coefficients a, b, c should be real numbers. Then only we call it as a quadratic equation. This is a statement. This is a rule to be a quadratic equation. So the reason is true. When you check the assertion, expand this because it is a whole square. So here I showed the expansion of it. 2x minus 1 the whole square. Use a minus b the whole square formula. Expand it. A square, that is 4x square. 2ab, that is 2 into 2x, 4x plus 1. Minus 4x square plus 5. When you simplify this 4x square and this 4x square getting cancelled. So I am getting the remaining terms as 4x plus 6 minus 4x plus 6. There is no power 2 term. There is no term with the power 2. So it is not a quadratic equation. So the assertion is also true. When both are true, I told you to use the CUTE rule. Now you see, reason is a standard formula. Assertion is a explanation or assertion is a question given. The reason explains about this particular question only. What is quadratic equation? What is the condition? So it has a connect. It explains about the reason is a proper explanation to the assertion. So we can go for option A. Very well, we can go for option A. Question 2. Assertion is the value of k equal to 2 if one root of the quadratic equation 6x square minus x minus k is 0 is 2 by 3. When one equation is 2 by 3, the value of k will be 2. This is what the conclusion. The reason says the quadratic equation ax square plus bx plus c equal to 0 and a is not equal to 0 has two roots. Yes, of course, the quadratic equation ax square quadratic equation have at the maximum two roots. So if I say it has two roots, it is a true statement only. Now you go for assertion the value of k equal to 2 when one of the 0 is 2 by 3. So when do we call this is a 0? When you apply 2 by 3 in place of x, it should satisfy the equation. Here I am applying it. 6 into 2 by 3 the whole square minus 2 by 3 minus x minus 2 by 3 minus k. So you simplify it, you will be getting k equal to 2. Yes, what they declared here is true. So assertion is also true. When two statements are true, what I told you have to check with that cute clue, cute tip. First, the reason is saying about the number of zeros. The reason is saying about the number of zeros of quadratic equation. But the assertion is telling about whether this value is a 0. Whether this value is a 0. How to check the 0 or factor of the equation. That is what the assertion is saying about. Both the statements are true, but this assertion not at all using this thing. It is telling about two roots, but here I have only one root. It is talking about one root. It is talking about substitution of the value, not solving the equation. So it has no connect. So the reason is not a proper explanation of assertion. So we go for option B. Question 3. Assertion. The values of x are minus a by 2 and a for a quadratic equation. So when you solve a, you will get two values minus a by 2, that means minus half a comma a. These are the factors of this equation. This is the assertion. The reason is for quadratic equation ax square plus bx plus c equal to 0, the value of x is minus b plus or minus root of b square. This root should be total. Root of b square minus 4ac by 2a. It is a standard formula. This formula is called quadratic formula, right? It is called a quadratic formula. What is the quadratic formula used for? It is used to find the value of x. So this quadratic formula is given. So whenever you are talking about the formula, easily you can check. So this is a correct formula. We can say the reason is a true statement. Now we go for assertion. They are telling these are the two factors, two zeros. So easily we can check by finding the sum of zeros and product of zeros. When you go for the product, it is minus a square by 2a into a square by 2. Sum of zeros is put LCM, 2 1 is 2, 2 into minus a minus 2a plus a by 2. So it becomes a by 2. Summation is a by 2. We know when sum and product is there, the quadratic equation will be x square minus sum of 0 into x plus product of 0. Already there is minus in the product, so it is minus of a square by 2 equal to 0. When you multiple these terms by 2, you will be getting 2 in the coefficient of x square and these 2's will get cancelled. So we will get the equation 2x square minus ax minus a square. This is what we are having here. So we can understand that these two are the factors of this equation. These two are the factors of this equation. in assertion but yeah, I'm getting here we are getting minus a x. When you simplify this, you are getting minus ax. But here it is given plus ax. Here it is given plus ax. Right? Yeah. So, if it is minus ax only, these are the zeros. If it is plus ax, these are not the zeros. Or directly you can use this formula and find the zero of this equation. This is what we have done here. We use the formula and find the zero. Some other value we are getting. We are not getting minus a by 2 or a. So the assertion is false. I told you any one of the statement is false. You go for option A or D. If assertion is false, go for the last option D. So the correct option is D. Check each and every symbol too. Then only you will get the correct answer. Question 4. Assertion is 3x square minus 6x plus 3 equal to 0 has repeated roots. I'll tell you what is repeated root. Repeated root means the same zeros. For example, in the equation you are getting 4, 4. This is called repeated roots. Okay. Reason. The quadratic equation ax square plus bx plus c equal to 0 have repeated roots if the discriminant is greater than 0. This is the reason. Now we check the property. Only when d is equal to 0, we will get equal roots. Repeated root is nothing but equal root. So the reason itself wrong. Once the reason is wrong, no need to check this assertion. Just go and opt option C. It's enough. Then question 5. Assertion. The degree of a quadratic equation is always 2. Hence, x square minus 1 equal to 0 is pure quadratic equation. Pure quadratic equation. I'll tell you what is pure quadratic equation. First, we check the reason. An equation of the form ax square plus bx plus c equal to 0 is known as pure quadratic equation. Yes, this is the correct statement of pure quadratic equation. In a quadratic equation, if only x square term is there, that is called a pure quadratic equation. Now, this is a true statement, so the reason is correct. But in the assertion also, it is having only one x square term and the constant term. Yes, it is also a pure quadratic equation. How do you get this is a pure quadratic equation? We can understand from this statement only. So, the reason is used in the assertion. The reason is explaining the assertion. So, I go for option A. Both the statements are true and R is the correct explanation of A. Then question 6, assertion. The equation 8x square plus 3kx plus 2 equal to 0 has equal roots, then the values of k is plus or minus 8 by 3. Question number 6. Assertion is the equation 8x square plus 3kx plus 2 equal to 0 has equal roots. Then the value of k is plus or minus 8 by 3. The reason is the equation of the form ax square plus bx plus c equal to 0 has equal roots if the determinant b square minus 4ac equal to 0. Yes, R is a true statement. Reason is the true statement. So we can say this is true. Proper statement. Correct statement. It is a property. It is a rule. Assertion. We will check that rule. They are telling it has equal roots. So equal roots means b square. B square is nothing but 3k square. So 3k the whole square is 9k square. And 4bac. 4 into 8 into 2. 4 2s are right, 8 8s are 64. So transpose it, 9k square equal to 64. K square equal to 64 by 9. K square equal to 64 by 9. Take root of it, k equal to plus or minus 8 by 3. Yes, it is also true. So assertion is also true. The assertion is used to the reason because the reason is the formula. Assertion is the statement where the formula is used. So it has a connect. So I'll go for option A. Question 7. Assertion. If the zeros of the quadratic polynomial ax square plus bx plus c equal to 0 are positive, then a, b and c all have the same sign. It's a little bit analytical question. We check it. Reason. If two of the zeros of a cubic polynomial are 0, then it does not have linear and constant terms. It does not have linear and constant terms. Two zeros of the cubic polynomial are 0. If you have cubic polynomial, you will get 3 zeros. Okay. Suppose first 0 is 2, second 0 is also 0, third 0 is also 0. Right. When you go for sum of zeros, sum of 0 is 2. Sum of product of 0 is 2 into 0, 0. 0 into 0, 0. 0 into 2, 0. So sum of product is also 0. Then product of all the three terms is 0. So sum of terms is the coefficient of x square. Sum of product of terms is the coefficient of x. This is for x square. This is for x. This is for constant. So these two will not be there. That is linear term and constant term will not be there. Right from x square term only you will have. So the reason is true. Now we go for the assertion. If the zeros of the quadratic polynomial are positive, zeros are positive. All 1, 2, 3. Quadratic, okay, 1 and 2, right? Both are positive. Then, if you write the term ax square plus bx plus c, ax square plus bx plus c. In this pattern, if you write the quadratic equation, all the a, b and c have the same sign they are telling. Okay. Just we check it with number 1 and number 2. Both are positive. Zeros are positive. So, how do you write the quadratic equation? X square minus sum of zeros into x plus product of zeros. Right? Now, for example, I have taken the zeros 1 and 2. Both are positive. So, sum of 0 is 1 plus 2, 3. Product of 0 is 1 into 2, 2. Now, I have a quadratic equation 1x square minus 3x plus 2. Here a is 1, b is minus 3. This is p, b is minus 3 and this is c. See, do all a, b, c have the same sign? No. So the assertion is wrong. When you take only positive numbers, when you summate it, the coefficient of the middle term becomes 0. Become negative, because it is the formula x square minus sum of zeros into x. So when you take positive number, definitely it becomes negative in the middle term. So this assertion is false. We go for option D. Question 8. The roots of the quadratic equation x square plus 2x plus 2 equal to 0 are imaginary. They gave one quadratic equation. They are telling that the roots are imaginary. Reason: if the discriminant b square minus 4ac is less than 0, then the roots of the quadratic equation are imaginary. Yes, this is the formula, this is the standard rule, so this is true. So we check it for this assertion. Here a is 1 x square, a, b is 2, c is also 2. Apply it in the equation b square minus 4ac. I am getting minus 4. Minus 4 is less than 0, which means the roots are non-real. Non-real means imaginary roots. So both are true statement. Both the statements are talking about the discriminant. That means to find the property of the zeros. So they have a connect. We go for option A. Question 9. Assertion: the positive root of root 3x square plus 6x equal to 9 is 5. When you solve this equation, you will get two roots. One of the root is positive, that root is 5. This is what the meaning of assertion. Reason is, if x equal to 2 by 3 and x equal to minus 3 are the roots of the quadratic equation, ax square plus 7x plus b, which is equal to 0, then the value of a and b are 3 and minus 6. Okay. They are telling, they give us the values of the zeros. If these are the zeros of this equation, the variable present in this unknowns a and b, these are the value they are declaring. Okay. So here the reason is also not a standard form, but you have to check, you have to do the calculation and find whether the reason is correct or what. Correct or not. Like this also questions can be asked. Okay. What I did first, they have given the zeros. No, I am finding the sum and product of the zeros to get, this is the quadratic equation. To get to the quadratic equation, and directly I will compare it with this given quadratic equation so that I can relate the corresponding term and find the value of a and b. So I find the sum of zeros. 2 by 3 minus 3, take LCM, you will get minus 7 by 3. This is summation. The product is 3 and 3 will get cancelled. So minus 2 is the product. We all know the quadratic equation is nothing but x square minus sum of zeros into x plus product of 0 equal to 0. So as we have 3 in the denominator, multiply all terms by 3. So x square will become 3x square. Here when you multiply it by 3, this 3 and this 3 will get cancelled. You will get minus 7x minus of minus 7x. So it becomes plus 7x minus 2 into 3 minus 6. So this is my quadratic equation. Is it correct here? What is that? 3x square. So a is 3. Yes, this is correct. Plus 7x minus 6. So in place of b also minus 6 is coming in the corresponding term. Though this is also correct. So reason is a true statement. We verified the values. It is true statement. Then now they are telling the positive root of this equation. As the given term is under root, what I do square root. It is given square root. So I square it on both the sides. I am getting 3x square plus 6x equal to 9 is squared, and I am getting 81 for 9. 9 9s are 81. Transpose everything to one side, you will get a quadratic equation. Divided by 3, all the terms divided by 3, you'll be getting this equation. So solve this using the quadratic formula minus b plus or minus root of b square minus 4ac by 2a. I am getting some combinations. Plus or minus minus 2 plus or minus root of 112 by 2. However, I simplified this root of 112. I will not get a value 5. So that assertion is false. I'll go for option D. Hope this video helps you in understanding different kind of concept used in quadratic. This video is not only helpful for facing assertion and reasoning question, it is a recap for you to revise this quadratic equation chapter also. All the best for your exam. Do well, children.